wanted to talk about more BDNF, of course. I'm always on the hunt for something that influences, affects BDNF, and I came across this book that I thought some of you might be interested in because she takes some stuff related, I'll tell you how it's related to BDNF, and turns it on its head. So, the name of the book, The Neuroimmunity by Michal Schwartz, and she, based on her research, makes this argument for how the nervous system and the immune system are much more intimately tied than we ever thought. So they've been having a sordid affair for years, and nobody knew about it. Come to find out. So what's really interesting is, you know, in medical school, one is taught that the immune system and the nervous system kind of stay in their separate corners of the boxing ring. So basically, I mean, because of the blood-brain barrier, you have this wall around the nervous system, and the gate to enter the nervous system, if you were in blood, would be through the choroid plexus. So it's this region of the brain where we make cerebral spinal fluid. And everywhere else, you know, there are tight junctions around the cells such that you can wall everything out. But at the choroid plexus, you have capillary beds, meaning the blood vessels there have holes in them so that small things can go across, and then you have this filtering system such that you take blood and turn it into CSF, right? That's what the choroid plexus is rumored to do, to the tune of about 1 liter a day. And it's the way then that you get the nutrients that you need to the brain. So in the CSF, there are very specific things that the brain likes. Oxygen and glucose, but it's this clear fluid that the brain basically bathes in perpetually. And then, but it's separate from blood. And this is how you basically prevent some things from entering that space. And it's always been thought that you really don't have the immune system really in the brain, and this is part of the function of the blood-brain barrier, is to protect the immune system, the brain, from the stuff that we don't want in it. However, per this Michal Schwartz research and other colleagues alongside her, basically, it looks like there's a lot more going on in terms of communication between the immune system and it. Not only might it be that, okay, there's a lot going on, the two are actually communicating, which, I mean, we could suspect that, but in fact, it might be that the immune system is a huge player when it comes to brain health. Now, naturopathically, this makes sense to me. But when do they talk? I mean, is it some kind of secret communication? In fact, it is, folks. So it looks like, okay, so remotely, you know, the immune system, there are some cells that end up hanging out at the choroid plexus, and those cells in particular are thought to be autoimmune T cells, which, again, this is another controversial piece because, I put that in quotes, I think it's becoming more accepted, but it has been thought, per the guy who got the Nobel Prize back in 1960 in immunology, more like, he's an Australian virologist, Frank McFarlane Burnett. He got the Nobel Prize based on his research on these, you know, these clonal selection lines of the immune system. So this idea that you have, when you're born or newborn, you start to develop basically a path of specific immunity, and also there's non-specific immunity. And then there are autoimmune cells that are present in the beginning, but they get destroyed, supposedly. And if any of those survive, well, then it's thought that that's how the development of autoimmune conditions happen, from the survival of these autoimmune T cells. But based on the fact that we've found autoimmune T cells in healthy individuals, and they're hanging out at this important interface between the immune system and the nervous system, it looks like they are bigger players. And in fact, they might be regulating BDNF. I mean, it's well known, according to Michal Schwartz, that the immune system and BDNF have quite the relationship going on. I mean, here we are, BDNF, another relationship BDNF has. So I'm telling you, keep finding out how this player interacts with everybody, gets around. And so another piece that was really interesting in this book, actually she alluded to it and I found it in her bibliography, was that these autoimmune T cells look to be protective after trauma. So when you have trauma, whether it be like traumatic brain injury or some kind of inflammatory type thing going on, there's potential then, so then the blood-brain barrier is compromised and you're going to have immune activity in the brain, which we've always thought, oh, that's bad. But these specific cells are the ones that tell the rest of the immune system not to destroy the neurons. Like, okay, we've got this damage here and let's keep it to here, so don't get these neurons as well. How freaking cool is that? So, read the book, Neuroimmunity, Michal Schwartz. She's out of the, what did I say, the Weizmann Institute in Israel. She's pretty much one of the authorities in neuroimmunity, which is a newly developing field. And it's probably a huge piece of how we maintain brain health. That, in fact, you know, we've always thought like the development of some of these neurodegenerative diseases, specifically Alzheimer's, is this inflammatory degenerative process that happens in the brain. It could be that we just need to amp up the immune system and keep the immune system robust and from aging, and that this could be the way to maintain brain health, or certainly a huge player in the process. Which, naturopathically, there's a lot about what to do for your immune system. So we'll go down this other rabbit hole here. But thanks for tuning in. Tell me what you think. What do you think of neuroimmunity? And if you found other stuff, let me know, because I'm always looking for more. So thanks for tuning in. Audio.